Good morning.
Good morning.
Good morning.
Hello.
All right, we'll give people a couple of minutes. So we were talking last week about how to bring vendor code in, and there was a small analysis done. They had that meeting. If we get the right people, we can go over that and finalize an approach, I think. Right. do we have any other topics?
Joe, this is Paul. In the lab POC group, we were discussing redfish and SZTP and how they relate and how we view them. And I wanted to bring that back to the TSC and have a quick discussion about that.
Okay, we can do the what do we call this thing? So do we know if John's going to join the call today? John Griffin.
I think he's away.
Okay.
He's on vacation, I believe, but I can share some updates on the meeting if you want.
Yeah, that would be good. I mean, I have the email, but if you wanted to go through it since I wasn't there, that would be great, Demetrius.
Yeah, so
Why don't we start with that one and then do the redfish and secure ZTP? And do you want to share the screen?
let me see if I'm prepared to do so.
Otherwise, I can share the email if you want to talk to that.
If you can share the email, I can talk through.
Okay, I'll do that. Give me a second. I just have to find the right window. That's the one. Okay, I got it right. Good. We don't have to edit after the fact. Okay, so start at the top. Okay. Anyway, this is who was there and discussed it. A good selection of people. So Demetrius, why don't you take it away? And I can zoom. Let me zoom a little bit for people.
Yeah, so the initial discussion was about the vendor plugin, right? So we have some vendor code and we have some generic code, which is OPI VPN bridge, and then we have some vendor code, which is the specific for each card that we probably have underneath, and that vendor code in that drawing that you see there are the blue boxes on the right. And now we need to understand or take a decision on how we are gonna include that vendor code into OPI and into OPI VPN bridge. So the initial approach that we had in OPI VPN bridge repo, it is the option one, where you have OPI EVPN bridge code, and then in the same repo you have like I mean, if you can scroll a bit to option one, Joe, yeah. So so the initial approach is that we had the OPI VPN bridge repo, and in the same repo we had like a tree of folders, which starts with the one vendor, and then goes to the IPU E2000 folder, and then inside there we was storing the vendor plugin code for the IPU E20000. And all of this was actually located in the same repo. No other repo was involved. And every vendor that wanted to actually put their code into OPI VPN bridge, then the only thing that was needed was to actually create an extra folder under this plugins folder with the name of the card, and put the code there. So that was the option one. And the option two is similar to this one, but instead of having the code inside the OPI VPN bridge repo, each vendor will have its own repo where they will store the vendor code, and the VPN bridge will actually copy the code over to the OPI VPN bridge repo in some location, and then it will build the binary altogether. So it will do a git clone first to clone the vendor code to OPI VPN bridge, and then we will build the binary. So that is the option 2. And the option 3 that we have discussed with our tech is
And
that.
so,
Mhm.
sorry to interrupt. On option 2, you said what you would do is you would clone the specific repo you need when you want to build it, when you want to do that build, and then build it in place. So it's
Mhm.
essentially a copy and build approach. Is that correct?
That's correct.
Okay, sweet. I understand. Thank you.
And the option 3 is that instead of having the code inside OPI VPN bridge repo or having it in another repo and clone it, what we can do is that we are gonna use the OPI Intel bridge repo, where today we have also where we have only Intel specific stuff, and in there we will have like a vendor folder which will hold like the vendor plugin code for EVPN. Okay, and we will actually import, not clone, but import the OPI VPN bridge libraries. So the OPI VPN bridge repo will not be the main binary, but it will be the libraries that we are going to use. And then we will import that on the OPI Intel bridge, and then we will build the whole thing as OPI Intel bridge binary, right? And is that clear what I'm explaining? So the vendor plugin call would be inside OPI Intel bridge, right? And then if we want to actually enable the EVPN functionality of the OPI Intel bridge, we will build the OPI Intel bridge binary by using the vendor plugin for VPN and import it also the binaries for OPI VPN bridge from the OPI VPN bridge repo.
So I guess the only thing that a little bit confuses me here is this association. I mean, I understand option 1 and option 2 in terms of who does what to who to actually
Mm-hmm.
accomplish the build. In option 3, I would have thought that this purple guy lives, in his own set of individual model or individual um, or equivalent plugins. And what you do is, in the build process is sort of equivalent to what it is in option 2, except you invert where the clone is done, but otherwise it would build very similar. In other words, I clone from here in, that's what this is showing. And
No,
then,
no, no. We will not clone. In this option 3, we will not clone. We will import libraries.
ah, okay, so in option 2, you clone the plugin
Yes.
code and build it
Yeah.
directly. In option 3, you well, then how do okay, so you're relying in that option, get it going into the actual makefile and call stuff. You're relying on okay, so you're essentially going to say, look, I'm going to pull what we used to call a dot A file in, an archive file in, a library. You're going to pull the library in as object code that the linker then resolves, as opposed to pulling in the code and building the object code.
I mean, okay. So the reason, what is it? What is why we need in option 2 to clone and why we need in option 3 to import? I will explain. In
Yeah.
option 2, I mean, the dependency goes from the IPU plugin, okay, imports stuff from a VPN core. Okay, so for instance, you have inside the VPN core, you have a library. Okay, and this library is needed in the IPU plugin. So the IPU plugin imports that library from core EVPN. Okay.
But it imports a built set of object code that you can link against. I mean, when you, I mean, library is used in a lot of contexts. So basically, I run the compile, and now I have object code that I can link against to get the final executable. And I'm going to import the object code, so I have to have an object code built over in the OPI EVPN bridge to import. And then every time I make a change, I rebuild that thing. How does that work? Because that's not normally the way. So mechanically, how does that work? Because I read the discussion, and it seems that maintainers are not preferring 1 and 2; they prefer 3. But I'm still a little mystified on. I'm a little mystified on why all the controversy, because you know the build process can take out a lot of the structural things unless I've got to start keeping object code and binaries sitting around in my repos for other people to use. Unless I'm doing something like delivering an SDK where that's how I want to deliver it, right? Because I don't want anyone, looking behind the scenes at the implementation.
Yeah.
So what am I
Maybe
missing?
I can.
Yeah, what am I
Maybe,
missing?
yeah, maybe I can share my screen so you can probably understand.
Yeah,
If
please.
I show you the code,
Yeah, please. Let's do
you
that.
can probably understand better, and also maybe I'm missing something, so you can help me with that. Okay. Let me go to the right repositories. Give me a sec.
Okay.
Okay, I will take the screen. Can you see my screen?
Yes, sir.
All right. So right now we are inside OPI VPN bridge. All right. And inside the OPI VPN bridge, we have a vendor plugin, and then which is related to the Intel E2000 IPU.
Mm-hmm.
Okay. And then inside there, we have the vendor specific code, and we have a dcgateway.go. So inside the dcgateway.go, the dependency goes this way. So here you import this thing. Okay. This thing, the InfraDB, as we call it, is a library inside OPI VPN bridge. Okay.
Mm-hmm.
So because the dependency goes from because you import stuff from EVPN core, as we call it, this InfraDB library is EVPN core. Okay. If you go with option 2, you need to clone the repo. If you put that plugin here, in a different repo, okay, in order to build the final binary, because you have this import right here,
Mm-hmm.
you need to clone it from the remote repository, to clone it inside the OPI VPN bridge, put it in some folder like this folder inside OPI VPN bridge,
Mm-hmm.
right? And then build the final binary, okay?
Mm-hmm.
Because of this dependency, because if you don't clone it, then it will just blow up because it tries to import something and it will not be able to find it, right?
Yeah,
Um,
and simply having okay, and so the make file though can do the clone, and the clone is only in your local build environment and temporary, effectively.
exactly. Yes.
Okay.
This
Um,
is option 2. This
yeah,
is option 2 that I'm explaining right now.
right. Got it.
In option 3, if um, you have to go to the how to explain this. So you have this dependency, okay, but this plugin will actually live in the Intel Bridge repo. It will not be anymore in its own repo somewhere else where we need to clone it. It will be in the Intel Bridge repo. So if we go to the Intel Bridge repo, for
Well,
instance.
okay. So hold on a second. So the
Mhm.
DCGW.go would live in the Intel Bridge repo. The
Yes,
OPI project, OPI EVPN Bridge package, InfraDB. The InfraDB would be often a different repo, just like it is in option 2, right?
yeah. The InfraDB will not change. It will be still in OPI VPN
Still
Bridge.
in this location, right? And then
Yeah,
I have a different directory that now roots the Intel E2000 tree that has the
gateway.
DCGW.go. That's a
Yeah.
tongue twister. Okay, I understand that, and I have effectively this import path to resolve. So I have to resolve this import path. The
Mhm.
import path today is resolved by it's all in the same tree. When I do the pull, I get or I do the get and create the local instance of the
You
get.
put everything in one place and you
So
build a binary. Yeah.
it's all
So.
in a structured tree. So I just have this path reference and it works. In
Mhm.
option, okay. Now, option 2 versus option 3, wherever this DCGW.go is, why wouldn't it? I mean, again, I have to change the path, but why couldn't I just clone the OPI EVP and bridge, which, okay, there,
Because you don't need anymore. Because you don't need anymore to do any clone. Because if you put it in the Intel Bridge, right? If you put this file or this vendor plugin path and this file, okay, to the Intel Bridge, okay, then you are handling OPI VPN Bridge as a library, nothing more that you import, okay. So
okay,
so in the option 2 you were building OPI VPN Bridge binary, okay, so you
yeah.
needed everything in one place. In the option 3 you don't build OPI VPN Bridge binary, you build OPI Intel Bridge binary. So in OPI Intel. Mhm.
But that okay. Why? But I could still okay. So I can in a single repo, can't I have a make file that builds you know a bunch of different binaries, 100 different binaries, and each binary is whatever package, basically whatever service you want or application you want or whatever word you want to use to describe that, right? So what I'm doing is I'm building a set of binaries off of external repos. So I have a set of repos that correspond to my set of binaries. I have a local directory that has the platform code in it, right? And in fact, you could imagine having a repo per platform or one that has a bunch of platforms. That doesn't matter for this discussion. What you do is you go to the platform and you say, hey, I want the hotel, um, the the super secret crypto and the EVP and bridge, right? You say build me those three, and what it does is the exact same thing you're showing me here, except that it starts from the point of view of the platform I'm building for, and
Mhm.
it goes and it grabs whatever it needs, either by cloning or by pulling in an already built library or whatever. It grabs those, puts them in the right place in the build directory structure, which isn't the same as the GitHub repo structure, right? Because all this cloning nonsense, basically you extend your build structure to have underneath. I mean, it changes these paths, but I don't understand how it changes the logic. And I believe I'm missing something important here. And maybe I just there again but that's the piece I'm missing, right? Because we've all done stuff like this before. And when I did this, I did exactly the same thing. I built for different platforms in a similar way, and it didn't require a lot of code structural change because the dependency that you're highlighting here in this Go file is the same path dependency in all the cases. It's just how you have to put the thing you're depending upon to get the build system to be able to go find the code, find the image, the code, the library. Does that make sense? My question? Does my question make sense?
Makes sense. And what you are describing exactly is the option 3 right now.
Right. No, that's what I'm saying, but I don't understand why it's a massive structural change to do option 3. I also don't understand why there's a big objection to, say, doing an option 2.
I'm not saying that is a big structural change to do option 3. Because this is what we are investigating right now.
Okay.
I mean, Artek said that he would like to see option 3 and he thinks it's possible and it's easy to do. Okay. And I was not 100% sure about that because right now uh, um, we have just tried the option 1 and option 2. Okay, but never we have tried option 3. And option 3 also requires current code to be moved around in different repos. So we are investigating this right now, and the signs are positive.
Oh,
So,
wait. Oh, not,
but I don't have a final result right now on the option 3 to say to you, yes, we can do it right now.
now
I'm just
I
saying
understand.
that the signs
No,
are positive.
yeah, this is great. Okay, so I'm not misunderstanding. Okay, now why is option 3 so preferred compared to option 2? What was the discussion there and what, because that doesn't come through in the discussion, it doesn't come through other than people's preferences, but there's no justification for the preferences. So why is option 3 so preferred versus option 2? Because I mean, I'll just say it. I don't see a major structural difference in the two. So why is option 3 so preferred? What was the discussion there?
I mean, I think, I mean, it's not so preferable from my point of view. Okay, it's preferable from Artek's point of view.
Yeah,
Okay,
but I mean, for the
but
people who,
I can explain. I
yeah,
can explain why I believe. Okay, so I will just give me a sec. I will reshare. Give me a second on that. Actually, let me go here. So we have this Intel bridge. Okay. And in this Intel bridge, in OPI, we have like um, we have some functionality regarding storage, right? So where we have like the specifics, I believe. I'm not an expert on that, but this is what I have understood. We have the specifics of the vendor code for Intel for storage, and then we have like the generic part, which is SPDK. Okay, and the SPDK lives in a different repo today. Okay, and we port that from this OPI Intel bridge. Okay, so in this OPI Intel bridge, we have everything that is vendor specific. Maybe it is storage, maybe it is networking for a VPN, but we have everything that is vendor specific. Okay, and for the generic part, like SPDK or OPI VPN bridge, we just import those libraries from the repos that they live today. Okay.
yeah,
Okay,
but
so I believe that Artex is preferring this one because this is like a common platform. So if you have like an IPU underneath, okay, you just download OPI Intel Bridge, and then you build your binary for EVPN or you build your binary for SPDK, and then with the right imports, everything will work.
okay, yeah, okay. So the relative advantage of option 3 is that I go to one place and I use my build system, my makefile, to decide which set of services I'm going to build and package. So if I was going to do a package for the IPU 2000, then what I would do is go to the IPU 2000 and do, make all, which would make all possible packages that are, within OPI, or I would do a make EVPN bridge or a make um, uh, storage or whatever, right? Again, maybe that's not the exact syntax, but that's the idea. And so
Yeah.
and then I could do, I could run a thing that says package made things. Just make up a syntax, package made things, right? And what made things are is all the things I just built, right? Because they all go into a particular uh, part of the directory structure. And the packaging software could create a package that could then be deployed to the IPU. So
Yes, it's something similar to that. I mean, you can have like you go to OPI Intel Bridge, and then you can have a command like make EVPN all, okay, and it spits out a binary that has packaged all the EVPN code for the Intel IPU. Something like this. And if you want SPDK specifics, then you do make SPDK binary, and then you get a binary which is specific for SPDK. Something like this. Of
right.
course, we need to find the right granularity, because right now in the OPI Intel bridge, you have a common main, right? And this main file, this main.go, which is like the starting point of any Go Golang program, right? It has hard-coded um,
So,
SPDK imports, right?
so
So,
that
but
so that's
if
a
you also,
yeah,
Mhm.
that's a mistake because
Yeah,
again, this is assuming, okay, this thing was assuming I'm only building the storage, or it was
yeah,
assuming
exactly,
I was doing essentially a monolith set of services, both of which are
exactly,
bad assumptions. So
yeah,
what you really need is for each thing you want to build, you need the main and the hooks for that.
hmm
And then it's not so bad because it's essentially move, you know, it's actually not so bad, but that means that the bridge has to get restructured a bit as well.
Yeah. So we need like a better approach on the main.go. We cannot have like just SPDK there. We can have, I don't know,
Well, so I don't think,
some cases, like some select
yeah,
cases, some switch cases where it says, okay, if we are building for a VPN, then you need to use those functions, and start the main with those functions. If you build for SPDK, you need to start the main with those
yeah,
functions,
I understand.
right? So
Well,
it
and
must be
I
a
would,
bit more clever.
yeah, and I would make the argument that you don't have main.go in this way because there isn't a single service, right? I mean, I've got Linux sitting there in all cases. I have at least a Linux sitting there. And what I'm doing is I'm installing services slash applications on top of Linux. And what I need for that is a set of mains, one for each service. And
hmm
those things can look like what's on the screen now. I mean, those things can for sure look like um, an SPDK specific bridge, right? Because now, so this was set up initially only for storage by Boris, I guess,
hmm
but it needs to be expanded to cover all the possible services. Then there's not a big lift change. You just have to lay the services out in parallel.
hmm
And it
Yeah, I
all
mean,
yeah,
you need like a build system. You
yeah,
need like something that is more clever. That so if you build for a VPN, then you just copy the main.go from some place inside here, and then you do the build, and then you use that main. I mean, it's just building functionality. I would say it is totally doable. I would say.
right. Okay.
And
Okay.
the second reason that not we believe, but Artec believed that this is better is because of the import dependency that we have in the vendor plugin. So in the vendor plugin, we import OPI VPN bridge code. OPI VPN bridge core code, as I have shown you before, this
Mhm.
InfraDB.
Yes, sir.
Okay, so if the vendor plugin lives here in the Intel bridge, and then we build the Intel bridge binary, then you can use the OPI VPN bridge core as just a library, right? That you can just import. But if you, because the dependency is this way, is from the vendor plugin, we import the InfraDB, which lives in OPI VPN bridge core. Okay, and that we believe can work. If you do not build the OPI Intel bridge, but you build the OPI VPN bridge, right? Then the vendor plugin should be cloned inside the OPI VPN bridge repo because of this dependency that you have, because of this import that you have, this InfraDB import, for instance.
Yeah. Yeah. It also means that, okay, so the fundamental structure of this, the core structure of this option 3 is, I think, then I have a set of build/mains or stubs
Mhm,
that let me build that service for the particular DP or IPU model
mhm,
or variant or whatever, right? I mean, again, the way in which you subdivide the uh, Intel bridge or the NVIDIA bridge is up to whatever is needed. I mean, again, you could have a emulated version, you could have a the 2000 version, you could have the 19,000 version, you could have all kind of things in there. And in each of those, for each of the supported services, you essentially would have likely a directory, although it could be done by file name, where you have essentially a main.go or a main.cc or whatever,
mhm,
main.py, that's your starting point for running that service. It's
mhm,
it's what a traditional main does. It does the initialization and it gives you something to build against. So when you build that thing, it then pulls in all of the code from all of the other repos it needs by library or by cloning or whatever technique is needed. And essentially what you end up with in a built Intel bridge or NVIDIA bridge or Marvell bridge is a structure that
Hmm.
reflects. And if you built absolutely everything in that guy, you would end up with, however many variants of cards are supported crossed into however many services. That's what would get built. And that's not okay. And that's not a terrible structure either if it's really done that way. So
mhm.
what has to happen is this main.go can't be main.go anymore, in my opinion. Does that make sense, or am I off again?
What do you mean cannot be main.go
Okay,
anymore?
okay, you don't want to use this main.go with all this SPDK stuff to do the EVPN bridge. The EVPN
Yes.
bridge is a separate application that's going to sit alongside the storage application. They're going to sit
Mhm,
together on the DPU and they both process different streams of packets. Right? And that's okay. And you might or might not build, I mean, you might build one or the other, or you could build both. And that's true for all the packages we would support. So what I'm saying is that I don't want this main.go. I need a different one. But
Yes.
the SPDK bridge needs this one.
Yes.
Okay. So that means you need more than one main.go,
Exactly.
right? You need one per application. That's what I'm saying.
Mhm,
So you end up with a cross product of the supported applications or a matrix of the supported applications versus the card models, the platform models. Um, and each platform could then, in fact, support different set of applications as their superset of all applications. And then if you're going to go use the stuff, put it in the lab or put it in production, you would build a subset of those applications, the set
mhm,
that you care about. So, for example, um, if I just wanted the EVPN bridge function plus maybe some deployment and telemetry stuff, I would build just those, package it, deploy it to the IPU, and everyone's happy.
Yeah, but it's as I said before, it is like we need a bit more to be a bit more smart in the building system that we're using and how we move around the main.go files, and
Okay.
also not only that, but how we start the gRPC servers. Okay, because if you have a gRPC server that listens for SPDK stuff, and then you have a gRPC server that listens for EVPN stuff, and both are up, then both today probably are using the same gRPC port, right? So all those things needs to be taken care of
So
because
this
you cannot
comes,
have,
yeah.
yeah.
So this comes into a proposal Mr. Sanders had about 18 months ago, which was to build a common dispatcher service for the gRPC, so that there was a common gRPC handler that then dispatched the gRPC request to the correct gRPC subhandler within the application for that set of the config and stats tree, because effectively everything ends up looking like a tree when you know, or rather it can always be transformed to look like a tree, so that's a good way to think about it.
Yeah, I mean,
And
you have multiple services that listen to some port, and you need some
so you
to
need a
be smart. Yeah,
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 you need a common dispatcher, and this is
yeah.
what Mark Sanders' very early proposals for how to structure the gRPC handling from a common DPU point of view. There should be documents sitting around that show that original structure.
Hmm.
So
Yeah,
we
I'm not against that.
yeah
I think it's the right approach.
yeah so we would need to effectively we would need to resurrect that part of the project and have it go forward. Now, if I did it the other way and I ever wanted to build two services, I would be back in the same dilemma though. I would have the same problems even in option one and option two as soon as I want to deploy more than one service, right?
Yes.
So I have to solve that problem no matter what I do. Okay. So
I
I'm
think
not against option three. I now understand the differences. I actually
yeah.
think option three does have some advantages structurally. And I think you guys are going to be okay. But again, I'm not going to put words in your mouth. I mean, from the discussion, my assessment would be that I don't think you've got to move too much around, other than this Intel bridge is going to need some thinking by Boris, Artek, Mark,
Mhm.
uh, to like, how does that structure really look? But they're sort of the ones who've been advocating for this, Boris and Arctic in particular. So they ought to be able to understand the how to restructure it. And okay, and I'm glad you didn't have option four, which is storage has OPI Intel bridge, and then EVPN has an OPI Intel bridge, right? In other words, we multiply out the repos so that every model and every service has its own bridge, because in that case, I'd rather option one. I mean, if that had been picked up, like, no, go option one's better. So, okay, good work.
So
Uh,
sorry, I haven't heard your last 30 seconds or
no,
so.
no, what I said is, well,
My
I'm just glad that what didn't come out of this was another option, which is a bridge per application per repo, because then the cross product shows up in the number of bridges, and that's bad. So, so I'm okay with option three as well. As long and I think option two could also be made to work. I prefer two and three to one. But let's see if we can make three work, because I
Mhm.
think long term I can see the advantage of it, because it gives us a way to do releases and release sets that's sort of sensible.
Yeah,
And
I agree. We still running our tests behind the scenes to see if we can easily move to option three, or there are any major disadvantages that we haven't yet checked Okay, and we have. I'm not against that. I just want to see if it is easy to do and does not actually bring us back like things must work. I would
Yeah.
say.
No,
So yeah.
yeah, no, I told that I completely understand as well.
Mhm.
But structurally, I think if it's not a big lift, then we should go with option three. And the two things then we have to do as a knock on to that are fix the main.go that you're showing here and fix that part of the structure and then resurrect the gRPC dispatcher. But in the case where you're only building one service, that won't affect you very much. And then
Yes. I mean, we can start initially with one service and then we can put the dispatcher in place. It's not
correct.
like a major priority, the dispatcher. Right now, we don't have, we don't even have a production environment for those bridges. So for the beginning, it's okay to not have a dispatcher,
I
I
agree.
guess.
Yeah, I agree. Oh, excellent. Okay. Anybody else have opinions on this? Did this whole discussion make sense? Did you guys follow?
I would like to say one last thing, if that is okay.
Please.
So everybody has like the full picture. In the OPI VPN bridge, even though that we will use it as a library, okay, um, we still have CI jobs, right, where we run like a simulated environment where we are creating like VRFs or logical bridges. Everything is related to EVPN objects in general, in order to test that the code is not broken, right? Because we have CI jobs in the OPI VPN bridge. So that means that even though that OPI VPN bridge will be used as a library, if we go with option 3, it will still have a main.go there, like it has today, right? In order to be used for CI purposes, okay, for
Mhm.
running those CI jobs. So it would be the same the same may not go as it is today, but instead of having cases like Intel and stuff like that, it will have only CI cases, where we will use that in order to run our CI jobs in those GitHub gates wherever somebody put some code there that we
All
need
right.
to run the gates against.
Okay. And so effectively what you're saying is that non um, non-platform specific unit test will stay local to the EVP and bridge, and other people could replicate that. And the alternative would be you'd have to externalize all of your unit tests into the common repo and have like a unit test target as opposed to a 2000 target. And that's painful because that means you have to go to two places anytime you want to mess with your unit test. So you'd rather the unit test always stay local.
I mean, the unit tests that are related and the CI jobs that are related to the core
Right.
code,
Yeah.
right? They should stay in the core code, and the CI gates should be run from the core code,
Yeah,
from the
that's what I'm
core
saying.
code
Because
repo.
the alternative would mean you'd have to take your unit test for each of the things and make that an external target, if you will, as well. But that sort of defeats the purpose of having self-contained CI and unit tests.
Yeah.
So I guess I don't see a problem with that. Um, okay, if the rest of it can be made to work, can you just type up the consequences of that, which is we need a common gRPC dispatcher for multiple services. The main.go has to be changed, or the structure has to be changed around it, so that you can build one to N services. The make file will have to go with that. And then that the CI related code, the service test code that doesn't depend on the bridge or hardware at all, also remains local to whatever module it is. So those are three consequences of this restructuring. And let's so could you just type up what those consequences in once you've finished the evaluation and say, yeah, we can do option three, but here's the additional stuff that has to be done.
I mean, I can write this email right now, even
Okay,
though that we
then do
haven't decided with option 3.
yeah.
I can just list the consequences if we
Yes,
go
please.
with option 3.
Yes,
Yeah.
please. Yeah.
Okay.
Yes, please.
Yeah,
That would
that's
be
not a
great.
problem.
And I don't see a problem with what you're suggesting with the CI stuff, but I don't want to have I don't want to come in a month and have another argument about it because we didn't bring it up front. So it's a good point. All right, cool.
Mm.
All right, thank you, Demetrius. That was great discussion.
Yeah, thank you, Joe.
Sure thing. All right, so Paul.
Sure. In the lab POC group, we've been talking about redfish versus SCTP and are they compatible? What are the differences? And Boris mentioned he's had several questions from people about how they interact, what are they, how would you use both of them together, all of that sort of stuff. And in order to clear up the confusion about that, we thought we'd bring forward a proposal. First off, that OPI has officially stated that SCTP is the provisioning mechanism of choice. And we've got that in our OPI provisioning lifecycle repo, and that we've adopted that as secure zero touch is our preferred method. And in that repo, we've actually said that redfish is explicitly out of scope for OPI provisioning. Nonetheless, the lab has been utilizing redfish as a provisioning mechanism. One, because none of the cards have enabled the SZTP components to get the benefit of using SZTP. So Boris has been using redfish as the provisioning mechanism in all of the tests that are run within the lab as it's built.
Okay.
So several folks have asked how they interact, SZTP and redfish, and they are alternatives to one another. They are completely separate functions, and you can use one or the other, or you could use them in concert. But just to clear it up, it's not like SZTP is you have to use it first and then you can shift to redfish. They have different capabilities and different pros and cons, but they are different approaches to the same provisioning problem. SZTP is, as it says, zero touch. If the card has, if the DPU IPU has the SZTP agent, the certificate, and the proper DHCP options enabled, the card will automatically get its IP address and go through its authentication and trust mechanisms with the SZTP server, and could, without any interaction, pull down an image, do what it's supposed to do what the SZTP server tells it to do. Redfish, on the other hand, requires that you know the IP, the user, and the password of the BMC on the DPU and IPU in order to kick off any action. So those are the benefits and the differences. What we wanted to bring here was, how do we want to remove the explicit out of scope mention of redfish from the provisioning.md in the provisioning repo?
Well,
And do we want to make it a first class citizen, a alternative that we can use?
all right. So I guess my first question is, if we went all redfish and revised our our specification,
Yep.
for lack of a better word, um, to say secure ZTP ain't it, use redfish always. what would we be losing? What does secure ZTP have that Redfish doesn't have? I don't know that answer off the top of my head. So did you guys look at that?
It's the zero touch provisioning. It's the you have to know something about the individual DPU, IPU that you want to interact with before you can interact with it. Whereas zero touch provisioning, that mechanism for getting the information about the IP address, the user, the password, all of that happens automatically when you power on the card. So that's the real difference between the two. In my mind, someone else may have a deeper understanding of the two methods, but that's my understanding.
But if we're using, okay, so do we then revise to say Redfish is the primary provisioning and configuration interface until you get to the individual services where you use whatever gRPC they implement, like we were just talking about in the previous section. And then you say, in addition, if you want to do automated, zero touch automation, if you want to do zero touch automation, then you use secure ZTP to do the discovery and establish the initial properties that you then feed to the Redfish engine, the Ansible script or whatever.
Yes,
because I suspect we're using all Ansible scripts with the Redfish code there,
correct.
right? So we could revise it to say, look, Redfish is really the cleaner way to do it. Everyone supports Redfish.
Yes.
But if I want zero touch, because I can do zero touch just to establish the initial state of all the things I'm going to manage, and then feed that to my Redfish scripts, so I don't have to do that part manually. And then we limit the secure ZTP to essentially discovery and what I would call bare provisioning.
Yep.
Again,
I like that proposal.
Okay.
I like the use secure zero touch provisioning to gather in a central place what is the IP address and the connection information for a particular DPU, and then use Redfish as the means to interact with it after gathering that info. Because you have to know that information in order for Redfish to connect and interact with the DPU IPU. And secure ZTP seems like an appropriate way to get that information.
Okay. All right. Questions or thoughts from anyone?
Hi. Yeah, I will talk to Julia, my colleague. But my understanding is that in general, we see Redfish as necessary. So I think this sounds very good. But let me check.
Okay.
Okay.
Not what I mean is I can't properly express Red Hat's opinion without talking to the experts.
No, that's great. Yeah, perfect. No. And again, I think your gut sense is correct and it actually makes more sense than only secure ZTP, especially because actual lab practice is doing it with Redfish, doing the configuration with Redfish.
And I think that's been our experience too, that in practice, Redfish becomes a requirement.
Yep. And I believe that all of the three cards that we're interacting with the most, the Intel now, the Bluefield 3, and the Marvell card, all have Redfish endpoints on them. So
okay.
The Intel card as of version 1.6.2 has a Redfish running on it, or can have it running on there.
Yeah. So can you?
So I will try to do that in the next week. However, it is holiday period. And I'm unsure if Julia might be away.
Right. Yeah. So can you type up, Paul? Can you type up a proposal and
Got
either
it, Doug?
huh?
That's essentially what I read to you. Was I typed this up and I've got it as a Word document right now, but I can
Yeah, we
send it
could
as an email to the list. Is that what you'd like?
send it to the email as a list or as a PR in the the OPI main repo where then send the PR to the list. Either way.
Okay.
Again, having a direct discussion of this kind on the mailing list is actually a very good use of the mailing list. And then people can respond on the mailing list with their official position. I mean, anything you say in this call is recorded anyway, so
Yep.
it's the same thing as the mailing list. So yeah, do that. So type it up, put it on the mailing list, and then we can turn it into PR if we need to. But let's do the initial comments and questions and any initial statements about it on the mailing list.
Can do.
Okay. And Demetrius, can we post that email that we were just referring to the mailing list as well? You could edit it if you like. You guys could edit it if you like, but you know, to show what the three options are, and let's put that on the mailing list as well. So can you guys who had that side meeting get together and do I don't know if there's anything you want to edit out of there, but let's send that the set of options and the one just state in there that we're working on option 3, and you can put the consequences one of option 3 in that as well.
I
Okay.
mean, John Griffith right now is on vacation and Artec also is on vacation, so I'm not sure if they agree to actually put that in the mailing list.
Well,
So,
I mean, okay, so I could edit it and do it
okay.
if you prefer. So send me
Yeah, that's fine.
yeah, send me the consequences list and that we just discussed, and
Mhm.
I'll post an edited version. I know what to edit on that one. It's fine. I'll do it.
Okay. Yeah, I will send you the mail then.
Nice. Okay. Anything else from anyone? We're just over time, but again, if you have questions, you can put them in the Slack or preferably on the mailing list. Or if you have alternate proposals, please bring them forward. And again, thank you, everyone. We'll talk to you next week.
All right. Thanks. And I sent that
Thanks.
already, Joe.
Great.
Thanks.